All right, welcome to the August 2026 Lunch and Learn. So typically in August, we like to focus on something that will be useful during the harvest, pre-harvest, harvest seasons. And I thought we've covered different things like sanitation, we've covered different additives and materials you might use during the harvest season besides yeast and things like that. One thing I really want to start covering next year is GAN, yeast assimilable nitrogen, and how that is important. And so you might see some resources and some lunch and learns centered around that, probably towards next year. But today I wanted to go back to kind of some basics and talk about lab analysis. There's a lot of lab analysis we do around berry maturity and around harvest time. And I know a lot of us have done these things many, many times, but it's always good, even for myself, to go back and review what are the proper techniques, what are some of the best practices. It's really easy to cut corners for lab analysis, and I'm here to remind you that sometimes that's not a great idea. So this is primarily focused on lab analysis you're going to do during the harvest season. So I'm not going to cover sulfur dioxide or ethanol or things like or malic acid. Really just going to focus on some of the ones that we do primarily during the berry maturity analysis as well as juice analysis. Okay, let's jump in. Let's see if I can get my slides to keep going. So important, obviously, for grape maturity, for juice sampling and juice analysis, and wine analysis as well. We do a lot of analyses like pH and TA as well. So the ones we're going to focus on today, total soluble solids or degree Brix, pH, titratable acidity, and I will mention yeast assimilable nitrogen. Not something I expect most wineries to do in their own lab. Some people may be able to, but an important one to consider during the harvest season. First off, I want to start by saying our website has quite a few resources. There's various newsletter articles that we've written over 10 years plus, and there's quite a few fact sheets at the ISU Extension store. And here's a series that colleagues of mine wrote several years ago on grape sampling for maturity analysis. And so there's one for how you should be sampling your grapes to take a representative sample of the entire vineyard. How to measure for total soluble solids or degree Brix, how to measure for pH, and how to measure for titratable acidity. Those are just for grape sampling. I'm not necessarily going to go through all the steps really in detail, but point out some really important parts. So check those out. Good explanations about the why we're doing this. Highly recommend you checking out those resources. And there's lots of other ones too, besides just the grape maturity series. There's one on wine faults. There's one on sanitation. I'd highly recommend checking that one out before harvest. And there's some other ones about other winemaking protocols. Okay, what general supplies do you need for a lab? You definitely need a dedicated clean bench space. Somewhere in the winery, you want to have a little kitchen area or, kitchen counter type area or table that is dedicated for your lab analysis. And it isn't necessarily open to the public. You are going to have some reagents that are not safe to be using by just anyone. So you want to have some glassware. Think about the different analyses you're going to be doing and what size of glassware you may need. And if you have any trouble sourcing these kinds of things, please let me know. There are different companies around that you can buy this from. And I actually even think Iowa State Chem Stores sells to individuals. If you're looking at that, let me know and I'll inquire about that. Make sure you have a source of distilled water. Buying from the store is totally fine, a gallon jug from the store. I highly recommend getting a squirt bottle. It just makes some of the things that you need to do with deionized water a lot easier. Distilled, deionized, they're both appropriate. Reagents, and you want fresh reagents that are not expired. So make sure you know where on your bottle the expiry date is and be checking that. And if you need to set a reminder on your calendar, do that. It's a good idea to maybe purchase new every year, especially things like calibration standards and reagents. Keep them in a cool, dry space, perhaps in a cupboard underneath or above, but do make sure that they are stored appropriately and not left. If you're beside a window, this lab looks like it's beside a window. Don't let the hot sun be shining on those reagents. I highly recommend getting some Kim wipes or at least non-lint tissues. Tissues like the Kleenex brand are linty, okay? Meaning that they deposit little bits of dust on your glassware. You want to get non-lint tissues. Kim wipes is the common example, so that you're not depositing any dust. Lab tape or a Sharpie to make sure that you can label your samples. That is, especially in the middle of harvest, you've got lots of samples you might be analyzing on a specific day. Make sure that you have a way of identifying those samples on the glassware itself, or put a little piece of tape, and make sure that you can tell samples apart from each other. And I would say a dedicated notebook that you can record your analyses. And when you go to start doing something that day, always have a date in there and make sure that that notebook is stored appropriately, and whoever needs to know where it is knows where it is. So we're going to jump into different analyses types. Oh, let me go back actually. The one thing I realized I did not include here, PPE, personal protection equipment. Please make sure that you have glasses, safety glasses. If you wear glasses, that's typically okay. If you do not wear glasses, you definitely want to purchase a pair of safety glasses. You can get that at any hardware store. Reason being, if you're using sodium hydroxide, if you're using any of these reagents, splash into your eye, trust me, it's not fun. I got sodium hydroxide was it sodium hydroxide? I got some reagent in my eye working at a winery once because I didn't have my safety glasses on. I had to go to the optometrist and get checked out. Don't do that. Just wear safety glasses. It's a really easy thing to do. It's probably a good idea to be wearing safety glasses when you're processing grapes in the winery anyway. Also, gloves might be a good idea. Some of the reagents, I mean, sodium hydroxide on your hands, maybe not a great thing. Nitrile gloves are a good idea to have on hand as well. Okay. So jumping into some of the analyses that we do during the harvest season. First one being total soluble solids using a hydrometer. So again, this is measuring your degrees Brix. And I know we use the term interchangeably. What you're measuring when you say, oh, I've got 20 degrees, 20 Brix, you are measuring total soluble solids. So it's measuring the density of all the soluble solids that are in juice. So not just the sugar, the acids that are in there, as well as there's flavor components, there's color components, there's all kinds of stuff in juice. But the overwhelming majority is sugar. So we can make an assumption that when you're measuring total soluble solids, you're essentially measuring how much sugar is in the solution. So we use the unit degree Brix. There's different units around the world, Ochet, Baume. Some hydrometers measure in potential alcohol directly. Refractometers or hydrometers can measure in percent alcohol, potential alcohol directly. So just to remind you, 1 degree Brix is the same as, or the units derived from 1 gram of sucrose dissolved in 100 grams of solution, or a 1% solution. So that's where Brix comes from. In this situation, and I'll talk about a refractometer on the next slide, but we are using a hydrometer. So a hydrometer is already calibrated, and they are expensive because of that. There's a little weight in the bottom here, and then a scale along the glass cylinder at the top, and it will be buoyant at a specific height, and that correlates to how much sugar or how is in the solution. So you add the hydrometer to a graduated cylinder of some type. It doesn't really matter, just make sure that it fits and has space around the larger portion of the tube. A good thing to do, especially if you are using this while you are fermenting or even juice, I would say, because there's some bubbles that can be created. You give it a little spin, and that spinning should unlodge bubbles that attach to the side of the cylinder. So you give it a little spin, it spins for, 10 seconds or so. All the bubbles can be released because you don't want those bubbles holding up that tube. That affects the buoyancy, right? And then you read the tricks or whatever the scale may be from the tube, the gradations that are already on the tube. And the one thing I want to point out, which is really important, when water touches the side of a container, it has because of capillary action, it has a bowing, let's say, or a natural curve to the water that climbs a little bit up the side of the glass container. And it's really important for any of these measurements, even with a burette, when we get to titrations, you read from the bottom of the meniscus. So the bottom of that curve to get the reading that you want to get. So important here that you're reading from the flat surface that is beside the tube. Okay, not right up against the tube, but you need to look out a little bit farther to where the surface flattens out. Okay, that's an easy way. A lot of people still use hydrometers, and that's totally fine. We're going to move on. A lot of people now are using refractometers. Refractometers, you can have a manual one like this one on the left, or a digital one like on the right. And it basically uses the refractive index of a solution. So light will enter the solution and it will bend. Well, it's going to bend one way, but the amount of the bending is dependent on the amount of sugar that is in that solution. So in order to do this, we need a refractometer, we need some water, and we need some tissue. I will say the hydrometer is easy because you need the hydrometer itself, and that's about it. You don't really need anything else to take a sample besides the sample itself. With a refractometer, this is where we're going to start to talk about calibration. Very important to calibrate any instrument before you get started. And I'm going to suggest, especially during the harvest season, when you're processing your juice as well, you need to be making sure that you calibrate daily. Okay? A refractometer is very simple to calibrate. On a manual refractometer, the way you calibrate is by loading the lens with deionized water or distilled water. Make sure there's no bubbles. Okay, that disrupts the flow of light. So you put a couple drops of water and close the lens cover. This is what you're going to see in the eyepiece. Okay, so you're looking down this way. You can hold it up to light so that you can see it a little bit better. For water, you want to adjust the blue line to 0. Okay, so if it is above or below the 0 line when you have water in there, you can use this little screw, or you take a little screwdriver and it fits right in there, and you rotate this screw here on the top until the water is at 0. That is how you calibrate. Really easy on a manual refractometer. On a digital, we've got a video, so we will show you. I would say if you are doing multiple samples, every couple of samples, every 5 samples or so, double check that water is still calibrated to 0, and so you're getting accurate readings. The reason calibration is important is just that. It's to get accurate readings and to make sure that you're not drifting one way or the other. And it becomes even more important, especially when we get into the pH meter. But I've got a video to show you of how to calibrate and how to use a digital refractometer. Let's play our video. Here we go. Okay, so we had some juice on there. We took our reading. We're cleaning the refractometer with deionized water between each sample, rinsing it with water into a waste beaker, using our lint-free tissue to dry that out. Between each sample, you need to clean with deionized water. Really, really important. Otherwise, the residual sugar that's left over, the residual solution will affect. So we've just checked. We have a 0.0 when we have just deionized water in there. The one thing I want to say here is if it didn't read 0, you would zero it out using the little calibration button, the 0 button, and double check it again with water. Okay, if you ever need to calibrate and you hit the little 0 button, check it with a second sample of deionized water to make sure that you are truly at 0. You can see that we dried it and we're ready to go on to the next sample. You just drop a couple of drops onto the lens, hit start, and it reads the sample. And when in doubt, these are really quick, easy analyses to repeat. If there's any doubt in your answer and you think, oh gosh, like that is way too low for what my brick should be, check it again. There's no harm in putting a couple drops on there and checking again. So moving on to pH. pH, very important, especially during the harvest season. pH measures the strength of the acidity in the juice or wine. Okay, so a lot of what I'm going to say is applicable when we have wine as well. pH is expressed on a log scale from 0 to 14, and there's no units associated with pH. Log scale just meaning that if you jump from 3 to 4, you are decreasing, so it's an inverse scale actually as well. You're decreasing your acidity tenfold. Okay, so each jump in numbers, each digit change in numbers is a tenfold change in the actual amount in the solution. So just an example, lemon juice is at about 2.2, milk is at about 6.5, toothpaste is at about 9.0 on the pH scale. Juice in wine typically is between 3 and 4. So that's the range that we are working in almost exclusively. So we measure it with an electrochemical probe. So the probe in this picture is right here. It needs to be calibrated daily, okay, especially during harvest. These probes are sensitive, they can drift, it needs to be calibrated with proper and unexpired calibration solution on a daily basis during the harvest season. Be sure that you have storage solution. This solution here, is storage solution, is the solution that's in this little container that the pH probe goes in at the end of the day. A pH probe is never, ever, 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 ever left dry. Okay. If we walk into a winery and we see a pH probe that isn't in a storage solution or water or some sort of solution, we may call you out for it. A minute here and there, you're prepping your sample, that's fine. Okay. But it cannot be left without being in a solution. If you go take lunch, at the very least, put it in water. Okay. Do not leave it dry. Okay, and then the filling solution. Some pH probes have a solution that needs to go inside. You can do that if that's the type of probe that you have, and make sure that you've got unexpired filling solution and that it's filled up to the appropriate level. Examine the fill solution and fill as needed. Between readings, you clean the probe and you blot dry. We have an example of that, so I don't really have to, but lint-free tissue again, and you don't want to be, forceful or aggressive with it. You just blot it dry to remove any water, but you do need to be a little bit gentle with these pH probes. I'll walk you through. There we go. Okay, so we're removing from the solution, the storage solution. On our particular probe, we do need to open the little valve for it to work, for the pH probe to work. Rinsing it with water. Again, always have a beaker with waste, blotting it dry. Making sure that the water is removed. So on our particular meter, we're going to hit calibration. We're going to start with our calibration standard, which is at 4.0. So we submerge, make sure that the probe, the bottom of the probe is fully submerged. That's what I'm trying to show here, is that this part of the probe is fully submerged. And we're going to let the machine read that. And each one, please read your instruction manuals carefully, because there's some nuances between pH meters. Before we use the next calibration, we are cleaning it. You don't want any carryover from one sample to the next, even in the calibration. We're going to use a pH calibration of 7.0. That's going to read. Our particular pH meter will say ready, or will stop flashing when it's red, or when it's stabilized. Okay, we're gonna clean that one more time. And I know this seems tedious, but you're doing this once a day, okay? And it is very important to do this. pH meters, like I said, they can drift very easily from day to day. You want to make sure that you are calibrating with the same calibration solution on a daily basis. So now we're calibrating with our last. 10.0 is this calibration standard. And at the end of this, again, with our particular, we are going to hit our measure because we're finished, or no, enter, sorry, enter. And this is to give us our slope. Typically, what we want to do is see our slope, and we want our slope to be between 97 and 103. That's our range of allowance for that calibration, and that just means that your pH meter is reading accurately. Okay, so that is a little bit about the pH meter. Make sure you understand how to use your particular pH meter. Make sure that you are calibrating it regularly. Make sure those calibration solutions are not expired and fresh. And as you can see, we pour out a little amount into a little vial so that it's easier to use. You can use a little beaker as well, but I think we reuse those a couple of times before we refill those vials up. Okay, next up, TA. The way I'm going to be talking about TA has a lot to do with pH as well. So what is TA? It's a titratable acidity. It's the measure of all of the acids in the juice or the wine. So it is important when it comes to sensory perception. It also gives us a good indication of ripening to know how much tartaric and malic and citric, which those are probably the primary ones, how much is in the berry themselves, because we do want to see that decrease during the maturity. Okay, so we perform a titration. If you did this in high school, or if you did this in first year university, you may have thought, oh, I thought I was never going to have to do a titration again. Well, we do plenty of them in our lab. So we do a titration with a base. So it's just an acid-base titration. And we usually do use sodium hydroxide. All of these procedures, I want to reiterate, on those fact sheets from the extension store. And you can find them on our website as well. Very detailed procedures of how to measure TA. We recommend using a pH meter and going to an endpoint of 8.2 instead of using a color indicator. The reason I prefer the pH meter is that way you don't have to worry about what color is your actual endpoint. when you have red wines and juices and white wines and juices and everything in between, it can be a challenge to figure out and to really pinpoint where your end point really is. So I prefer, most of you have a pH meter. You should have a pH meter. So there's no reason you can't do this. And it saves you from buying another reagent. Your sample, especially when you are fermenting, should be degassed. So you just want to, spin it or really give it a good shake to get out, release any dissolved CO2. You do want to do constant stirring or swirling. We'll have a video of this. Use a defined amount. We use 10 mils in our particular analyses. Again, read through that protocol. When you fill up the burette to begin with, and I highly recommend you get a decent burette, and if you need help sourcing that, let me know. You will not have any sodium hydroxide in the bottom. So you open up the stopcock into a waste vessel, and some will start to flow, but sometimes you get these bubbles that linger. You need to get rid of those bubbles, okay? Because they can wreak havoc on the volume that you're trying to determine with this titration. So you want to make sure that there are no bubbles. I should have a big X through here. And the way to do that, open the stopcock really quickly until you get those bubbles to release. And then do not forget to record the starting volume on your burette. Lots of people forget and they start doing their titration and then realize, I don't remember what I started at, therefore you have to do it all over again. Similar to the hydrometer, you want to read the bottom of the meniscus for the burette. So this reading, I would say, is at 11.9. Okay, that is the bottom. If you want to go an extra decimal point, you can, but 11.9 is sufficient enough for us to record that for this analysis. You perform the titration. And when you get close to the endpoint, you really do need to go drop by drop or you'll overshoot very quickly. When you're close, just a small drop of sodium hydroxide is going to push that pH far. So you can see that with this video. And I'll probably talk over this video a little bit. So we want to make sure that the pH meter is going during the entire analysis. I am manually swirling. Don't get spillage like I did. We're manually swirling the beaker. A slightly larger beaker would be good. You may notice this is a lot more than 10 mils distilled deionized water. We added 50 mLs. There's no change in the end result, but it gives you enough solution so that the pH meter can be submerged. So you can see I'm swirling with my right hand. That's my dominant hand, reaching behind to open up the stopcock. Now we're at around 7. We're going to start going drop by drop, get a feel for how your burette works. And I think we are there. Okay, so we're at about 8.2. We're going to let this stabilize. That's another important part. Make sure that you allow the measurement to stabilize, especially if you're using pH. Even if you're using a color indicator, make sure that the color remains for at least 15 seconds before you write that down as your final volume. Okay, so I'm just making sure that everything, I think I added another drop there. And another important thing, especially if you're using a color indicator, have a white background of some sort, white piece of paper, or laminate a white piece of paper so it doesn't get wet. And I think that's about it. I'm reading. Okay, so now I'm reading the final volume. Make sure if you can't see it very well, you give yourself some help. You can, and that is how you do a titratable acidity. So how do I do the calculation? I pulled this out of the fact sheet. We've got our titratable acidity as tartaric acid. Okay, so that is the unit. It's grams per liter of tartaric acid is how we denote. And in this particular example, I had an end volume of 25.6. That's what I read when I had my hand up. My initial volume from those pictures before, 11.9. So I had a total volume that I added to titrate the wine. It was 13.7. The normality or strength of my sodium hydroxide was 0.1. I used 10 milliliters of wine. So I do this calculation and I came out with a titratable acidity of 10.275, or 10.3 is totally fine to write down. You could, if you're going to use the same amount of wine and the same amount of, or same concentration of sodium hydroxide every time, you just take big V, okay, the difference between the two volumes, multiply that by 0.75. So that's a kind of a shortcut that you can use. But do understand where it's derived from. Lastly, just wanted to point out yeast assimilable nitrogen. And so this is a measure of available nitrogen for the yeast to use as food source during the fermentation. So it's important for yeast health and to allow them to multiply and multiply and multiply. And if they are healthy and fed, they will not produce H2S. If they are struggling, they will produce H2S in the middle of our fermentation. So you may already have enough yan from the grapes in your vineyard. There is a wide range that I have seen, even over the past couple of years, of yan around this state. You might think, oh, we're really fertile. Lots of nitrogen in the soils in Iowa. Not necessarily. Not necessarily in our grapevines and not necessarily in our fruit. Like I said, large range. Lots of deficient vineyards, some vineyards that are almost too much yan. You can add yan in the winery. You can use DAP or Fermate O or Fermate K. Randall Voss and our group doing a lot of research on this right now, so stay tuned to some of those results. A range for a healthy fermentation is approximately 150 to 300 milligrams of nitrogen per liter. Okay. That's a very specific unit. So be careful when you're looking at using one of these products that you're converting it to a milligram of nitrogen. Okay. A milligram of DAP per liter is not the same as a milligram of nitrogen per liter. And I can help anybody run through calculations for that. So when we measure yan in the lab, we measure two things. We measure the ammonia that is in the juice or the grape, and we also can measure primary amino nitrogen. So that just means amino acids. So those are the two things that we measure, and they're two separate analyses. Okay, so yan, that's one of the reasons yan is a little bit more expensive than some of the other analyses that we do. They are colorimetric assays, meaning that we do a reaction in a little cuvette and we get a color change. But it's not a color change that we can see by our eye. It's a color change that only a spectrophotometer can see. So this is where there are several wineries around the state and probably around the Midwest that have spectrophotometers and might do their own yan determinations, and that's awesome. There's lots of people, though, that are not set up to do this. We can perform this in our labs. Like I said, we offer this for $56 because, again, there's those two analyses that we have to do. It varies widely from vineyard to vineyard. You may ask me, do I have to do every single cultivar, every single block? What I would say is if you're interested in having yan tested for your vineyards or the vineyards that you're getting grapes from, please reach out to me. We can have a conversation about, the history of the vineyard, if you've ever done yan testing before, if you're fertilizing, things like that. And I will walk you through what I think you should test. If it's every variety, if it's maybe every variety to get a baseline this year, and then going forward, you don't need to do absolutely everyone. It is year to year dependent. If you have questions about yans, please reach out. Happy to go through this with you because each vineyard is going to be very individual. And we want to make sure that we come up with the best strategy of testing for you. Okay. So to wrap up some of these things, berry sampling, just a quick note about berry sampling. Again, please check out that fact sheet that we have. Make sure you are obtaining a representative sample, meaning you're not just going and collecting two clusters and taking one berry, squeezing it into your hydrometer and getting an analysis. That is absolutely not the way to do that. You need to take a representative sample of your vineyard and juice at least 100 grapes or so many clusters and test a sample like that. And then you also want to do that over numerous time points to see the progression of the maturity and the ripening in your vineyard. Make sure during the harvest season that make sure that you're performing your lab analysis. Make sure that you carve out a piece of your day, or you have a dedicated employee to do these analyses that is trained and knows how to do these. Make sure it's a calm, quiet environment. I know there's lots of things going on, but you really do need to focus when you're doing some of these lab analyses. Keep notes with dates associated with them so that you know when you perform those analyses and on what samples. Have your winery's procedures documented and readily available. And I say that because you could be in the middle of an analysis and forget how to do something, or you have a new employee and they should be able to have a document that they can follow along. If you need help drafting some of those documents, let us know. We'd be happy to give you a hand. Order new harvest chemicals, and if you haven't done so, do it now. We are almost there. Wineries in Nebraska, I know, picking last weekend. So order harvest chemicals if you need to now. Calibration is a must, especially with a pH meter and a refractometer. You need to calibrate your instruments to make sure that you're getting accurate results, and ones that if you do an analysis today and then let's say you do an analysis in a couple days for berry maturity, you can compare those results with confidence. And these are just calibration standards for our pH. This is also a stir plate. This could be very helpful to some people, especially if you're doing titratable acidity and you want to keep that sample stirring. They can be inexpensive. You may be able to get one from a supplier. So a little stir plate like that and you put a little magnet stir bar in there, could be a good little investment.